Hi, everyone. So I will be talking about TOR and Vanity domains. Yeah, let's start. So TOR is the onion router. So it's basically a web traffic anonymizer. So you can be anywhere in the world and you can go visit a website and no one will be able to know where you are. This is how TOR works according to EFF. First of all, we start with Alice being the user with the computer. She obtains a list of TOR nodes from the directory server Dave. Let me just open a pointer. So Alice gets a list of TOR nodes from Dave. So Dave tells her which of the TOR nodes she can use. And then Alice will pick or the TOR on Alice's computer will pick a random path to the destination service, which is Bob's website. So she will be going through green links that are clear. So Alice to the first TOR network node, and then the exit node to Bob, which is also green. And then everywhere in the middle, these are red links, which are like encrypted traffic. So basically, Bob can't tell what Alice's IP address is or who she is. And Alice doesn't know anything about Bob either. So everything in the middle is like, think of it as an onion. So an onion has a bunch of layers. And so that's how traffic is routed through. So if Alice wants to visit a different website like Jane's, then she would just go through a different set of servers with a different exit node. And then, so now Bob has no clue what Alice is doing with Jane. So basically only the computers that are directly connected to Alice, which is this one, knows where she's trying to go. And then only the last exit node from TOR knows that to send Alice's traffic to Jane. So basically everything is super secure. So there's two versions of TOR. The original version was V2. So that was 16 characters. And then there was a newer version, which is V3, which is the current one, which is 56 characters. So this is actually the super long one because it's using better crypto. It's got an improved directory protocol. It's got better onion address security because of the longer URL. So there's less chance of collision. And we have SHA-3 and better algorithms versus SHA-1 and not so great algorithms. And basically there's a whole new method of how TOR is like a massive upgrade, and it was called Proposal 224. So there's something called MKP 2240. So it's called Make Proposal 224 Onion. It basically generates the ED 22519 keys used by TOR. It's an open source program on GitHub. And it replaces projects like Shallot that Facebook used to get their TOR domain. So Facebook used something called Shallot to get a TOR v2 domain, a vanity URL or vanity domain. That was Facebook core wwwi onion. And they reversed the acronym, and then they marketed it as Facebook's core World Wide Web infrastructure, but it was basically BS. And they got the Facebook, they basically put the filter Facebook into the program called Shallot, and they got their onion domain. And what I just did with HFCS, the computer science club server in the past month or so, was basically use MKP 2240 to generate this domain, which I now use for my personal website. So this is Raymond Li, whatever. I basically put in the filter Raymond Li, and then it took 2 weeks on the 48 threads of 3 AMD Opteron cores from 2012 and got this domain. So MKP 2240 actually runs on any platform, including Windows, where you have to use WSL, but any Nix platform runs on Mac OS. And different platforms will require different optimizations. So let's say you're on an ARM platform, you would basically have to optimize it differently than if you were on like Windows or Mac. So let me just bring up TOR so I can show you how that looks. One sec. All right, so here's TOR. So if you go to my website, which I have here. I have it set in TOR to automatically direct it to the TOR URL. So you would basically, instead of seeing the regular link, it would find the Onion page, and then it would redirect to the Onion link automatically as soon as the page loads. If you don't have that set, you would have a button up here that says, like Onion site available. Choose the Onion site. And so now we're on the exact same website that I have that's on Tor because it's on my server. And as you can see, we're at the Vanity Onion URL. So I can do a live demo of how exactly it works, but I'll just go through a brief description on how the MKP2240 actually works. So we first have to install any required dependencies on any Debian-based distro. This would be sudo apt install git. We need GCC. We need libsovian dev. We need make and autoconf. And then we will clone the GitHub repo from cathugger, cd into the folder, run the autogen to generate the configure because it's C, and then /configure with any options. And I'll talk about options in a second. But you can visit this link to get the list of optimizations. Basically, the program is optimized for different architectures. For example, if you're on ARM, if you're on x64, etc., you would have different optimizations to make it run faster. So that would be compile time optimizations. Once you do configure it, you would make, and then you would run the binary. So let's go ahead and do a quick demo. So because I'm on Windows right now, I have access to multiple distros through WSL. So on Ubuntu, we would basically first install the dependencies, and then we would git clone, and then we would just cd into the folder, so we can see all the files that we've just cloned. Run autogen, and then run configure. But we will run it with options that are optimized for my computer. So I'm using a Ryzen 9 3900X. So I have it basically running AMD 24K. So infilter is like because I don't need that long of the filter, I'm just going to go with a really short filter. So 2 to the power of 5 would be, so 5-character filter, or something slightly longer than that, I think. And then we would have the batch number, which is useful to make it work very well. So basically, we'd run make, and then we can use, so we have the binary MKP2240, and then we would run MKP2240. So I'm running with the SBD CS Club flags. So S is getting it to print out some statistics. B is getting it to, so S, this is like the statistics that S prints out. We see the filter, so it's running it with one filter. We've already found a domain, so it will keep going and find more domains until we tell it to stop with just Control-C. And I ran it with directory mode, so it's going to dump all the files into the CS Club directory. And then we have the -B mode, which is batch mode. So I actually filed a pull request for the program to include batch mode as the default, because it was not the default a few years ago. But in the next release, it should be the default. So batch mode is up to 50 times faster than non-batch mode, which is crazy. So let's just go into our newly mined, or I call it mined, but it's really calculated from the hash, the hashes of the private keys. So we have 2 of these hashes. Let's go to one of them, and then we see we have host name, the public key, and the secret key. So if we just cat the host name, we just get the host name of the Onion domain, the Vanity domain, which we would basically put into our TOR configuration, and then have TOR use this domain to serve our web page. So then once you go to this domain, once you set it up on your server and you go to this domain in Tor browser, for example, you would be able to access your website, your web page. So that's the setup for Ubuntu. Now for Arch, it's actually really easy. I have VA installed. It's an AUR helper. So MKP2240 is actually available on the AUR. So we can just install that. And the way we would optimize it on Arch would be to edit the PKG build and then find where the options are, and then just basically delete all this build stuff and change OPT to whatever options we want. So in this case, I'll have enable Donna, actually we will get rid of the enable Donna because that's not the best on my machine. So we added our options and then we just save that PKG build and then have it install any dependencies. So in this case, libsodium is the only one that's not installed. We'll have it install, and then in this case, we can just, once it finishes installing, because it's now installed to our bin folder. So if I do which MKP2240, we would see it's installed in user sbin. So now I can just directly run. I can just directly run without the /, and it would start generating, or would start generating vanity URLs with filtering this filter. So we can see some stats. So clearly this is, that's how many calculations per second or how many like random one it's trying. This is the number of successes per second. And then there's the time lapse. So it basically took me 2 weeks on the CSC club to mine my domain, which was Raymond Li, which was 9 characters in the filter. As you can see, CS Club is 6 characters in the filter, so it's much faster. So it's like an exponential time complexity growth with a longer filter. So yeah, that's how we get Vanity TOR domains with MKP2240. And hope you guys will have an opportunity to try this, and hope you enjoyed my talk. Thank you.
Thank you. If anyone has any questions, send them in the Q&A right now and we will respond. We will start the other talk in like a second. If you guys don't have any questions.
Can
Thanks for the applause,
panelists?
guys.
Yeah, panelists can ask questions for sure.
Okay, but I can't type in the Q&A.
Just say it.
Oh, okay. Well, I was just going to say, can you repeat the name of the main tool that you use to generate this?
Yeah, so the name is MKP2240, which stands for Make Proposal 224 Onion. So Proposal 224 was the TOR v3, the newest version of TOR. So basically, we're making an onion domain. So MKP2240.
Okay, I guess I put it in as 0, but it should be an O. All right.
Yeah.
Thanks.
And you can just Google this. This is like a super famous utility.
All right.
And there's actually people who have done time complexity analysis on different platforms. Yeah, so someone, anonymous attendee is asking, where can we learn more of this? So if you just Google it, you can find a lot of tutorials on how to use it. The GitHub README actually teaches you how to use it, and like with installation and usage, and how to actually put the generated stuff into TOR so that TOR can use it. And then, yeah, so that's how you can learn more about this.
There's also a question in the chat. How much does each additional car multiply difficulty by?
So it would be, I think it was 2 to the power or something. So exponential time. Yeah, it was 2 to the power of something. So if you have 5 characters, it would be 2 to the power of 5, which is 35. But then you would multiply that by like, there's an algorithm. So if you search up, I'll put it in the chat. If you search up T-Brindis MKP2240, this guy has a great analysis on the time complexity of the program. Just Google that, and then, yeah.
We have one more question in the Q&A. What is the name of this concept?
Which concept?
Whoever asked that, would you like to clarify which concept?
Either in the chat or in another
Q&A.
question.
Yeah.
Vanity URLs. What is the name of this concept? So, okay, there's not really a name. It's just, yeah, sure, vanity URLs. So vanity basically means look good. So URLs that look good are, because if you just install TOR will actually randomly generate you a URL that will be just a nonsensical string of random characters that are within the base 32 representation of the hash. So certain characters like 1, 2, and 8, 9 are not allowed. But basically with MKP2240, you can generate your own addresses that are like vanity so that they look good. So in my case, I have like Raymond Li, whatever. So then people know that's my website. That's my TOR domain. And it's really hard to impersonate this any further because I have it at 9 characters. So if anyone would to go like to make it seem realistic, they would have to go at least like 11 or 12 characters, which is statistically going to take a very long time.